Right, good day and welcome. Mr. Simons here. In this lesson, we're going to look at determining first derivative by means of first principle, and I've done the 4 basic variations all in one go. Right? So, say first derivative, simply equation that gives us the rate of change at any instant that is referred to as my first derivative. First derivative of fx is notated as f prime x, and it's read like that, f prime x, not f dash x. No? So f prime x, and f prime x is the rate of change of function f with respect to the change in variable x. Right? If equation is given as y instead of f of x, and y is a distance or location, then we usually label f prime x as dy dx, change in y with respect to x. So we change in y with respect to x, but that to look in later lessons, right? So let's look at the problem. So determine the first derivative using first principle, very important. So when we're required to determine the derivative of a function by means of first principle, old school method, they call it the H method. We use f prime x, meaning first derivative of x equal limit h tends to 0, fx plus h minus fx over h. So, question number 1. Determine the first derivative of the following using first principles. So, f of x equal 4x plus 2, that's given. So, first we'll always find fx plus h. So, there in the place of x, I have x plus h. So, here in the place, I have x plus h. 4 times x gives me 4x. 4 times h would give me 4h plus 2. So for f prime x equal limit h tends to 0, fx plus h minus fx over h. Fx plus h should become 4x plus 4h plus 2 minus f of x, which was 4x plus 2. So I have 4x minus 4x, which becomes 0, 2 minus 2, which becomes 0, and I'm left with 4h. So you can literally check whenever we simplify these two, the only items that must be left must contain a h in it. Now 4h over h and h cancels, so I'm left with limit h tends to 0, 4, and the limit there of a constant would stay 4. So here we have a constant rate of change. Right, let's look at the quadratic. Right, so here in gamma 2 we have a quadratic. Find first derivative using first principle. That's what's given. So first principle, I'm going to use this equation. So f of x equal x squared. In the place of x now, I first have to find x plus h. So x there becomes x plus h all squared. So I have two terms and it's squared. Please don't forget there's a middle term. X times x, x squared. X times h gives me xh times the 2 gives me 2xh, and h times h would give me h squared. 1 mark for getting the correct equation. Second mark, because I said first principle, I have to write the equation. So f prime x equal the limit h tends to 0 of fx plus h minus fx over h. So 1 mark for the equation. My apologies. Then we substitute in the equation. So fx plus h is x squared plus 2xh plus h minus f of x, which is x squared. Again, x squared minus x squared cancels, and all that must be left must at least contain 1h. So you see I have 2xh plus h squared. Right? From there, you see I can't substitute h tends to 0 in because then it would become undefined. So therefore, we always only take out h as a common factor. So if I take out h as a common factor, 2xh divided by h gives me 2x. H squared divided by h gives me h. H and h cancels, so I'm left with 2x plus h. So now I can substitute h equal to 0 in there, and it tends to 2x. In short, if you look at it, and we're going to learn the different methods or rules of differentiation. 2 times 1 there gives me 2. 2 minus 1 gives me 1, so that gives me 2x. So in short, what you've calculated, the steepness slope as the rate of change of the curve is 2x. So the rate of change for parabola is a straight line equation. So there, 1 mark for the answer, 1 for taking out h, 1 for simplification. So 1, 2, 3, 4, 5 marks. So in exam, we're going to either test quadratic, cubic, or hyperbolic. Alright, let's look at the third one. Alright, so find the derivative, or first derivative of following using first principle, fx equal x cubed. Right, so fx equal x cubed. Right, so because we must guess first principle, that x would become x plus h cubed. I'm going to do the long process before I do the shortcut. So x plus h cubed is the same as saying x plus h squared times x plus h. So if I do x plus h squared, x times x gives me x squared. X times h times 2 would give me 2xh. H times h gives me h squared. Right? Times the x plus h. X times x squared would give me x cubed. X times 2xh would give me 2x squared h. X times h squared would give me xh squared. H times x squared would give me x squared h. H times 2xh would give me 2xh squared. H times h squared would give me h cubed. Right, now if we add my like terms, I have x cubed. 2x squared h plus x squared h would give me 3x squared h. Plus xh squared plus 2xh squared would give me 3x h squared plus h cubed. So in short, we need to remember, you see all of that I've done, get no marks for. You only get 1 mark for getting to the final part. So when I substitute here and I say fx plus h, x plus h cubed, remember would give me x cubed and h cubed at the end. And in the middle, it's simply 3 times, so 3 times 1 would give me 3. Take 3 minus 1 would give me x squared h. Therefore the h 3 times 1 would give me 3. 3 minus 1 would give me h2 with the x. Or in short, should now see here Fibonacci sequence 3, 2, 1 for x, and for h it goes 1, 2, and 3. The 2 middle terms simply have 3. So go memorize this. In short, x cubed, x squared, x to the power 1, h cubed, h squared, h. 1, 3, 3, 1. Right, so go memorize that. Very important when we test it, that you can go straight from here, straight to there. Right, so for first principle, we're going to say f prime x equal limit h tends to 0, f x plus h minus fx. So there I'm writing in my equation, minus x cubed, right? X cubed minus x cubed cancel, and everything that's left behind must contain an h, right? That's because I have to take out the h as a common factor and cancel it to the bottom so that I don't make the equation undefined, right? Or the expression. So here I have 3x squared h plus 3xh squared plus h cubed left. Take out h as a common factor, 3x squared h divided by h, 3x squared, h squared divided by h gives me h cubed divided by h gives me h squared all over h. H and h cancel, so I'm left with 3x squared plus 3xh plus h squared. So in the place of h now, I can substitute 0, h squared, 0 squared, and that simply becomes now 3x squared. And as I say, when you do rules of differentiation, 3 times 1 gives me 3, 3 minus 1 gives me 2. So that is 3x squared. So the steepness slope is the rate of change of curve, is 3x squared. So on the rate of change of a cubic function, it will always be the equation of a parabola. Right, now let's go to the one that learners complain about, hyperbolic. So find the derivative f prime x of the following using first principle, f of x equals 2 over x. So I have 2 over x, in the place of x I have to substitute x plus h, so the x at the bottom simply becomes x plus h, 1 mark. First principle, so I have to write f prime x equal limit h tends to 0, f x plus h minus fx divided by h. So I have 2x plus h minus 2 over x. Right? Now to add two fractions, I assume, remember, the denominators there must be the same. So I'm going to say x times x plus h. You see there? Then I'm going to multiply, cross multiply 2 times x. Gives me 2x, and there 2 times x plus h. Right, so that gives me 2x minus 2x minus 2h. The bottom x times x would give me x squared plus xh. The division there, I so much change to multiplication, and remember that's h over 1, so if I invert it, gives me 1 over h. Alright? Whatever doesn't contain a h will always cancel. So you see that 2x minus 2x cancel, and I'm left with minus 2h. So minus 2h over x squared plus x plus h times the 1 over h. This h and that h would cancel. Alright, so now the bottom there will not become 0 and therefore not undefined. So I'm left with minus 2 over x squared plus xh. Right, now if I substitute h tends to 0 in the place of h, that would be x times 0, so I'm left with minus 2 over x squared. So you see positive 2 over x, first derivative of it, positive will always become negative, and I increase the x by another x to get x squared in short. But we will look at the shorter way. So first exam question would be any one of the three. Quadratic, cubic, or hyperbolic. Straight line is a bit too straightforward to ask. Right, so make sure you understand. I'm going to do them separately. More examples. If you enjoy the lesson, please subscribe, like, and share the video. Bye.